Hello everyone! In this tutorial, we're going to talk about something super cool, the forces of filtration in the glomerulus. Basically, these forces are what help move fluid and solutes out of the blood and into the Bowman's capsule. It's like a little filtering system inside your body. These forces are known as Starling's forces and are also observed in capillary circulation. So, when it comes to understanding how fluids move through our bodies, there are two forces at work. The first one is called hydrostatic pressure or pH. This force is created by the pressure within a vessel, which compels fluid to move out of the vessel and into surrounding tissues. A great example to understand hydrostatic pressure is to think of a water bottle with a small opening. When you squeeze the bottle, the pressure inside increases, and water flows out of the small opening. The same is true for our blood vessels. The more blood there is, and the higher the blood pressure, the faster fluid will move out of the capillary walls into the surrounding tissue. The second force is the oncotic pressure, or pi, which is a type of osmotic force created by the presence of proteins in the blood and tissues. Proteins are large molecules that are too big to pass through the walls of blood vessels, so they remain in the blood and create a gradient that attracts fluid towards them. So, always remember that oncotic pressure is a force created by proteins in our blood that attracts water towards them like a magnet. This helps to keep the water where it belongs in our body and is essential for fluid balance and preventing dehydration. Now, as a recap, hydrostatic pressure is a force that moves fluids out of the blood vessels from the high-pressure compartment, the blood vessel, to the low-pressure compartment, the interstitial fluid. Meanwhile, oncotic pressure is a force that counteracts hydrostatic pressure by drawing fluids back into the blood vessels. Proteins in the blood generate oncotic pressure by attracting and retaining water molecules. Now, to help visualize these forces, I drew a glomerulus. On one side, we have the afferent arteriole, and on the other side, we have the efferent arteriole. And in between them, we can see the glomerular capillaries. Finally, surrounding all of this is Bowman's capsule. The three forces that act in the glomerular filtration are hydrostatic pressure. This is the pressure exerted by the blood against the walls of the glomerular capillaries. It is the primary force driving filtration, pushing water and small solutes through the glomerular filtration membrane and into the Bowman's capsule. The second force is the oncotic pressure. This is the pressure created by the presence of proteins, such as albumin, in the blood plasma. These proteins attract water, creating a force that opposes filtration and pulls fluid back into the glomerular capillaries. Then, the third and last force is Bowman's capsule hydrostatic pressure. This is the pressure exerted by the filtrate that has already entered the Bowman's capsule. It opposes filtration, pushing fluid back into the glomerular capillaries. Together, these forces determine the net filtration pressure, which determines the rate of glomerular filtration. Note that there is no oncotic force in the other direction, and this is because under normal circumstances there should not be any significant amount of protein in the filtrate. The net pressure, referred to as P-net, is a measure of the overall force acting on the capillary walls. It is calculated as the difference between the force pushing blood out of the capillaries and the force drawing fluid back into them. In a healthy adult, the hydrostatic pressure of the blood within the capillaries is typically around 55 mm of mercury, while the hydrostatic pressure of the filtrate is around 15 mm of mercury. The oncotic pressure is approximately 30 mm of mercury. By plugging in these values into the formula, we can determine that the net pressure is equal to approximately 10 mm of mercury. I hope you found this tutorial helpful. If you have any questions or comments, please feel free to leave them below.